Hello, Bharat Kumar. So I will explain this question. The population density of an insect species increases from 40 to 46 in 1 month. If the birth rate during that period is zero point 0.4, what is the death rate? So we have to find out death rate. So we have an equation including d value. What was the equation? Is there any equation including d value?
Delta n by delta t is equal to bn minus dn.
So we have dn by dt is equal to Rn. Of this, R is given by B minus D. So in the question, they have given only 40 and 46. What is this 40 and 46?
N is
This is the
40.
change in population size or population density. So initial population size was 40 and in the next generation it increased to 46. So this delta n by delta t is 46 minus 40. That is rate of change of population size. So it will be 6. This delta n by delta t is 6. So we can substitute this 6 in this equation. And what was this n? Do you remember that n? What is this n?
Initial population.
N is the initial population size. So we don't know this R value. So we can take it as R. Then we have N value. It is given in the question. Initial population size is 40. So R into 40. Now we can find out the R value. R is equal to 6 by 40. So R value will be 0.15. Is it clear? So we have started with delta n by delta t is equal to Rn. Now we have this R value. And there is an equation connecting R, B and D. What was the equation?
R is equal to B minus D.
R is equal to B minus D. So we know that R value is 0.15 and in the question they have already given that D value is 0. B value is 0.4. We have to find out the D value. So D is given by B minus R. is 0.25. So option 1 is the right answer. 0.25. Is it clear?
Yes, ma'am.
Miss 0.515 is equal to 0.4 minus D അല്ലേ അപ്പോൾ D is equal to B plus R തന്നെ വരൂ.
D is equal to R is equal to B minus D.
ആ ഓക്കെ
Clear
B
അല്ലേ?
minus R B minus clear.
There is one more question in the same pattern. Try to do this question. Are you able to do this question? Is it over? So your answers are right. I will explain this question if anybody has not understood. So the population size of a bird increased from 600 to 645 in 1 year. So initial population size was 600 and in the next generation it increased to 645. if the per capita birth rate of this population is 0.125. That is, R value is given in the question. This per capita birth rate and intrinsic rate of increase both are same. They are referring R max. Per capita birth rate and intrinsic rate of increase both are R max. So in the question, R max is given 0.125. So don't get confused when seeing per capita birth rate. It is the same R max. So we have to find out death rate. Sorry, in the question they have given birth rate. R max is per capita rate of increase or intrinsic rate of increase. Both are R max. Per capita rate of increase. Here they have given per capita birth rate. That is the same B. Per capita rate of increase or intrinsic rate of increase. So we have to find out the D value. This is the same pattern as the previous question. So firstly we have to find out the R value. R value is given by, we know that here delta N by delta T is 45. So 45 is equal to R into N. Here N is 600. So R is given by 45 divided by 600. That is 0.075. Now we have this R value. So we can easily find out death rate. So equation connecting death rate and instantaneous growth rate is R is equal to B minus D. 0.075 is equal to 0.125 minus D. So D is given by 0.125 minus 0.075. So we will get 0.05 as the answer. So third option is the right answer. Is it clear? If you have any doubt, please ask. Hello, is it okay?
Yes.
Okay.
Try to do this question. Is it over? So I will explain this question. The net reproductive rate R0 is 1.5 for a given population. So in the question we have R0 is equal to 1.5. If N1 the population of females at generation T is 500, N1 is also given in the question, that is 500. Then what will be the population of females after 4 generations? So we have to find out NT plus 4. So we have an equation for finding out the population size of future generation. Do you remember that equation? N0 is equal to R0 NT into R0 N0 into R0 raised to T. So here we want to find out population size after 4 generations, that is NT plus 4. So N0 into R0 raised to 4. Here we want to just substitute the given values. N0 is 500 into R0 is 1.5, the whole raised to 4. 1.5 raised to 4 is 5.0625 into 500. So we will get 2531.25. So second one is the right answer. Here all the values are given. We want to remember this equation and substitute these values in that equation. Is it okay? Is there any doubt? So try to do the next question. This question is a little bit confusing. We cannot directly apply these values into the equation. I will explain this question. If gypsum egg density is 160 at time t, while doing this type of questions, you have to write the given values at the first time. So you can save your time. If gypsum egg density is 160 at time t, so nt is given by 160 and 200 at t plus 1. nt plus 1 is 200. What will be its value at time t plus 3? So we want to find out gypsum egg density at time t plus 3. Assuming that egg density continues to increase at constant rate. So for finding out population size in the future generation, we have one equation, nt plus 3 is equal to nt into r0 raised to t. Here it is 3. So we have this nt value. What is nt? Please respond.
160.
160. We have 160 as nt, but we don't have this r0 value. So we have to find out r0. So we know that this nt plus 1 is nt into r0 raised to 1. Isn't it?
Yes.
So nt plus 1 value is already given in this question. So 200 is equal to nt is also given in the question. So 200 is equal to 160 into r0 is not given in the question. r0 raised to 1. So r0 itself. So r0 becomes 160 divided by 200. 16 by 20. 1.25. So now we have this r0 value. There is a correction. R0 is in the right side. So R0 will be 20 by 60. Sorry, 200 by 160. Is it okay? Now we have R0 value. So we can easily find out gypsum egg density in at time t plus 3. So just substitute the R0 value in this equation. So we will get nt plus 3 is equal to nt value is 160. 160 into r0 value is 1.25, the whole raised to 3. 1.25 the whole raised to 3 is 1.953125 into 160. So we will get 312.5. That is option 3 is the right answer. 302. Is it clear? So what is asked in the question is, you have to find out nt plus 3. So we know that in order to find out nt plus 3, you have the equation nt into r0 raised to 3. But we don't have this r0 value. So you have to find out r0 value from the given terms. That is 160, 200. Is it okay?
ഒരു ഡൗട്ട് ഇതില്
Can
ഫസ്റ്റ് T2 T+1 ആകുമ്പോൾ ഇൻക്രീസിംഗ് റേറ്റ് 40 ആണ്.
once more.
And 160 to 200 T2 T+1 the difference 40 ആണ്. അത് assuming that intensity continues to increase at constant rate அப்படி சொல்லும்போது T+1 T+2 ஆகும்போதும் T+2 T+3 ஆகும்போதும் இன்க்ரீசிங் ரேட் 40 அப்படி கால்குலேட் பண்ண முடியுமா? ஐ மீன் ஒவ்வொரு ஜெனரேஷன், അതായത് ഈ T-ന് T+1 ആകുമ്പോ 40 കൂടുന്നത്. അപ്പോ T+1 T+2 ആകുമ്പോഴും അതേ 40 കൂട്ടിക്കൂടെ?
കോൺസ്റ്റന്റ് റേറ്റ്
കോൺസ്റ്റന്റ് റേറ്റില്
കോൺസ്റ്റന്റ് നമ്പർ എന്ന് പറഞ്ഞിട്ടില്ല.
കോൺസ്റ്റന്റ് റേറ്റ്
They have said constant rate. It is not constant number.
ആ റേഷ്യോ ആവും കോൺസ്റ്റന്റ് അല്ലേ? കോൺസ്റ്റന്റ് നമ്പർ ഓക്കെ.
Is it clear? So now we are moving to logistic growth. So in the case of geometric growth and exponential growth, we are assuming that resources are unlimited. That's why we have got a J-shaped curve. But in the case of logistic growth, we are assuming that resources are limited. So in the case of logistic growth, resources are limited. So the graph will be like this. Firstly, there will be an increase, but at some point, population's growth will stop. This point can be called as carrying capacity. Beyond this point, population size will not increase. So carrying capacity is the maximum amount of resources supported by the environment for the growth of population. Maximum amount of resources supported by the environment for the growth of population. Beyond this carrying capacity, there will be no resources available for the population to grow. So population growth stops there, and this upper boundary for the growth curve is called as carrying capacity. In the case of logistic growth also, there is an equation for finding out the rate of change of population size. So it is given by delta n by delta t is equal to Rn into k minus n by k. R is the instantaneous growth rate, n is the initial population size, and k minus n by k is the proportion of unused resources remaining. It is the proportion of unused resources remaining. N initial population size. R instantaneous growth rate. It is the same as equation for exponential growth, but here we are introducing k minus n by k. It is the proportion of unused resources remaining. So remember this equation, delta n by delta t is equal to Rn into k minus n by k. So I will give you some values. Find dn by dt value according to these. K is equal to 1000. R is equal to 0.1 and n is equal to 100, 500 and 900. So you have to find out dn by dt values for these values. There will be 3 dn by dt values. First substitute n is equal to 100. One I will do for you. Dn by dt, our equation is dn by dt is equal to Rn into k minus n by k. So we have R value as 0.1 and n value 100 into k minus n by k. That is 1000 minus 100 by 1000. So 1000 minus 100 is 900 divided by 1000 is 0.9. So 0.1 into 100 into 0.9 is given as 9. So when the initial population size is 100, the rate of change of population size is 9. Nine individuals will be added to the next generation. Now you have to find out rate of change of population when the initial population size is 500. Find out by substituting n is equal to 500. Do you understand? Instead of this 100, substitute n value as 500. Have you done? So we have dn by dt is equal to Rn into k minus n by k. Our R value is 0.1 into n value here 500, k value 1000, 1000 minus 500 by 1000. That is 0.5. 0.1 into 500 into 0.5. So we will get 25 as the answer. So 25 is got when n value is 500. Also we have delta n by delta t as 9 when the n value is 100. And one more case is there when the n value is 900. So delta n by delta t is equal to 0.1 into 900 into 1000 minus 900 by 1000. We will get 0.9. Sorry, 0.1. This 0.1 into 0.1 into 900. So we will get 9. So this we have understood that when the n value is 100 and n value is 900, the value of delta n by delta t is 9. But when the n value is 500, then rate of change of population size is 25 value as compared to this 9. From this, it is clear that maximum growth will be exhibited at half carrying capacity. We have in all these examples, carrying capacity value was 1000. Isn't it? Carrying capacity, that is the K value is 1000. So here N value is 500. That is half the carrying capacity. Here K value is half the carrying capacity. So when N value is half as the carrying capacity, rate of change of population size is maximum. Is it clear? When the
Yeah, got
population
that.
size is half as the carrying capacity, then there is a maximum population growth. Is it clear? Does anybody want to repeat?
Clear, ma'am.
Okay, so try to do the next question. It is related to logistic growth. Are you done? These logistic growth equations are clear for you. Hello? Do you have any doubt? Hello, am I audible?
And this question, how we can do?
Hello?
The last question,
Shan,
how
can
we
you,
can do?
are you able to do that question?
No, no.
Hello? Do you understand logistic growth equation?
Equation I understand, guys. The last question actually solved for me.
So I will explain this question. A population is growing logistically with a growth rate of 0.15 per week. So R value is given in the question 0.15 in an environment with a carrying capacity of 400. So carrying capacity, that is K value, is also given. It is 400. What is the maximum growth rate that this population can achieve? This question is an indirect question. We cannot directly apply the logistic growth equation here, but all the hints are there in this question. So they are asking maximum growth rate. When will a population will achieve maximum population growth or maximum growth rate? I have already told you that maximum population growth will be exhibited at half carrying capacity. So in this question, we have to find out the growth rate, that is dn by dt or delta n by delta t we have to find out. For logistic growth, the equation is given by delta n by delta t is equal to Rn into k minus n by k. Do you remember this equation?
Yes, ma'am.
Yes.
For doing this question, we have to know all the values for these terms. That is, we have to know R value, N value, and K value. But in the question, they have given only the R and K value. These two terms are known, but we don't know the N value. But they are already asked in the question maximum growth rate. So a population can exhibit maximum growth rate at half carrying capacity. So they have already given us a hint, that is N value. What will be the N value?
200.
N will be half of the carrying capacity, that is 200. Now just substitute all these values into this equation. So we will get 0.15 into 200 into k minus n by k, that is 400 minus 200 divided by 400. So we will get 0.5. 0.5 into, hello, is there any doubt? By multiply, hello,
Continue.
by multiplying all these terms, we will get 15. So first option is the right answer. Is it clear now? So sometimes the question will not be in a direct mode. They will ask indirectly also. Is it clear?
Yes, ma'am.
Yes, ma'am.
Anybody want to repeat?
Miss, last
Please
question. Repeat.
share
Miss.
screen.
ഇപ്പൊ ലാസ്റ്റ് ചെയ്ത ക്വസ്റ്റ്യൻ ആണോ?
അതെ.
ഓക്കെ. So in this question, they have given this. I will read the question. A population is growing logistically. So it is directly given in the question. It is logistic growth. Logistically with a growth rate of 0.15 per week. So in the question, R value is already given 0.15 in an environment with a carrying capacity of 400. So carrying capacity is also given. K value is 400. What is the maximum growth rate that this population can achieve? So do you remember the previous example? We have already done an example. K value is 1000. R value 0.1 and N values as 100, 500 and 900. Do you remember this example?
Yes.
So in this case, when the N value is 100, the population growth rate is 9. And when it is 500, population growth rate is 25. And when it is 900, population growth rate is 9. From this, it is clear that maximum growth rate will be exhibited at half the carrying capacity. You can see that carrying capacity here is 1000. Isn't it? And here the N value is 500. That is half of the carrying capacity. This is K by 2. We know that K is 1000 and 1000 divided by 2 is 500. This 500 is the value for N. So when the N value is half of the carrying capacity, the population can exhibit maximum growth rate. Is it clear? Is this concept is clear for you?
Yes, ma'am.
The same concept can be applied in this question. So in the question, they have given R value 0.15 and K value as 400, and they are asking for population growth rate. But they have mentioned maximum population, maximum growth rate. So we know that maximum growth rate is exhibited at half the carrying capacity. So in the question, they have not given the N value. But for finding out growth rate, we have to know the R value, K value, and N value. And we can substitute these values into our equation. Our equation is delta N by delta T is equal to Rn into K minus N by K. So by knowing these three terms, we can find out the growth rate. But in this question, they have not given this N value. This N value is not available in the question. But they have given what is the maximum growth rate. So this maximum growth rate is exhibited when the population size is half of the carrying capacity. So we can find out the N value, that is K by 2. Is it clear? Now we have the R value, K value, and N value. And just substitute these values into this equation. Then we will get 15 as the answer. Is it clear? Hello? Who was asking? Sean?
Ma'am.
Is it clear?
Clear, ma'am.
Do you want to repeat?
No, it's clear.
Hello, is it clear?
Clear, ma'am. Clear.
Okay. So that's all about logistic growth. We can continue the next class. Thank you.
Okay.
Thank you.
Thank you, ma'am.